It's Fun Friday, a chicken's least favorite day. Get it? Friday, fried a chicken. Advanced placement calculus here, instructional video. This is Friday. You got a weekend coming up. You got Monday. You got your AP Tuesday at 2 p.m. I think it's 2 p.m. It's on the website. Hope you've looked at that demo by now and you have your plan for how you're actually going to upload your answers. They say that 2 days before the advanced placement exam, you'll be emailed your e-ticket, which is what you're going to use to actually enter your exam. You can only enter the exam on one device, okay? So if you want to enter it on your Chromebook or a laptop or a desktop, that's fine. But then when you use your phone to take pictures, make sure you email them to yourself or upload them to Google Drive. Might be the best way to do it. If you want to use your phone, it should be a lot easier. When you want to upload, just hit the button. It'll say, use a picture, take a picture. You'll be able to take a picture of your work. It's just going to be not so easy to look at stuff like this on your phone screen, zoom in. I got an XR. It's not bad, but if you're using like a 4S, I don't even know if anybody's using that at this point in time. It might not be so easy to see, okay? So, think about that. When you do your demo, please put in the work to know what's going on here. When you get emailed that e-ticket, so 2 days before the exam, does that mean 2 actual days or 2 school days? Because if it's 2 school days, you should be getting it today on Friday. If it's 2 days before the exam, you'll be getting it on Sunday. If you haven't been receiving emails from the College Board, I've tried to be on top of these things. I send you reminds. I put it on the website. You're supposed to have figured this out by now. It might be in your junk folder. Just so you know, if you can't receive the email, you're starting to freak out. If you log into My AP, on the day of the AP exam, you should be able to enter your exam that way. Just Google, My AP login, and hopefully it'll take you there. Practice that beforehand, just in case you don't receive the email. And log in a half hour before your exam. That's important. You got to fill out personal information. Make sure you log in early. Don't screw up the AP exam because of clerical nonsense, okay? Here, cool little accumulation function problem. Something's a little bit weird. Part B, they ask you something that I've never really seen on an AP exam before. So you see what I'm talking about when we get there. These are not from the College Board. They are from AP Classroom, but I could tell just by the fonts and the way questions are asked that they're questions that teachers have uploaded. Great questions. Sometimes a little bit different from the way they do things on the AP. You'll see one like this on the homework. You'll especially see an accumulation function with something with an X in front of it in front. I think it's 2X. That one's an AP one that was in the past. That's a great one to practice. Just like your other differential equation problem, great one to practice. I really feel like you're going to see differential equations. Really feel like if you see a graph of the derivative or an accumulation function, they're the same types of problems. They've also, had those ones where they just tell you what a derivative is equal to. So look, practice these. Make sure you practice the problems that I'm giving you over the weekend. Let's rock and roll. The function g, what up G, is defined on the closed interval -4 to 8. The graph of g consists of 2 linear pieces and a semicircle. It's right here, the other linear piece, constant, is shown in the figure above. And let f of x be this guy right here. So f of x is a function that involves an accumulation function. Remember, what you always want to do right away is take the derivative, so f prime of x. So the difference here is that the derivative of f of x, you start with a 3 in front, right? 3 plus, when you take the derivative of an accumulation function, drop in that variable upper bound for the independent variable. Integral sign goes away. dt goes away, okay? So here's what f prime of x is equal to. It's actually not g of x, okay? You need to take g of x and shift it up 3 units for it to be f prime. More on that soon enough. And now, still, if you take the second derivative, though, f double prime of x is going to be equal to 0 plus g prime of x. So at least I got this information right here to help me out. Or if I accidentally justify in terms of f, I should justify in terms of g. I got a little bit of a relationship right there, okay? F of 7, no big deal over here. F of 7 equal to 3 times 7 plus the integral from 0 to 7 of g of t with respect to t. All right, so that's really going to be 21 plus the integral from 0 to 7. Okay, so this is kind of cool. You got to split it up into 2 integrals here. Here from 0 to 7, and then here from 6 to 7. The function's not continuous, but you could still get the area of this section right here, which is 3. That's easy to see. And the area of this section right here, it's just a semicircle. So 1/2 pi r squared. Just remember, r in this case is 1, 2, 3. So 1/2 pi times 3 squared. So is that 9/2 pi? Just be careful, by the way. You're integrating forward the regions below. So the integral is going to be negative. So negative 9/2 pi. And then integrating forward the regions above, the integral is going to be positive positive 3. So really, weird looking answer for an integral right there, but whoop, there it is. Whoop, there it is. Come on now. Whoop, there it is. Here we next want f prime of 7. Cool. F prime of 7. Well, check it out. F prime of x is 3 plus g of x. So f prime of 7 would be 3 plus g of 7. Some people are like, how do I get g of 7? It's right here. Here's the y coordinate that corresponds to an x coordinate of 7 on the graph of the function g. And that's going to be 3. So it's really 3 plus 3, which you and I know is 6. But stick it to the squirrels, man. 3 plus 3. Deal with it. Just kidding. These are the people grading your exam. That's an easy one to put a 6, okay? It'll make it easier for them to grade your exam. But I wouldn't simplify, okay? It's too easy to make mistakes with simplifying. God, if you screw up 3 plus 3 by simplifying, I could see it, by the way. I could see it happening. Don't tell Harrington. He'll get really mad. Part B is going to have something weird. Find the value of x on the closed interval -4 to 3, at which f attains its maximum value. That's an absolute maximum. Absolute max. How do I know it's an absolute max? It says f attains its maximum value. It's the maximum y value of the function. Another tip, it's a closed interval, okay? And surely that must be some sort of test, okay? And if you want to know where f attains its maximum value, you want to draw the f prime line. That's where I draw the line. The f prime line, okay? But the f prime line is the same thing as the g of x plus 3 line, or the 3 plus g of x line. And look, g of x goes from -4 to 8. Remember, if you add 3 to it, it's just going to shift it up 3 units. So it's still going to go from -4 to 8. It just gets a little weird because, to draw this, you need the graph of 3 plus g of x. You need to take g of x, shift it up 3 units, which is really tough here because they didn't give me space up here to do it. And could you imagine doing it on your laptop? You can't do it. So hopefully you don't get one exactly like this. But if you take the points, I'll just do a couple points right here. I'll shift this guy up 1, 2, 3. So he's supposed to be all the way up there, a little bit higher than that right there. This point go up 1, 2, 3 right there. So really that's this piece right here. It's this piece shifted up, doing the best I can right here. This point go up 1, 2, 3. So that's the bottom of the semicircle. So it's going to do a little something like that. Then this point go up 1, 2, 3. It's actually going to be right there. And now if you shift this thing up 3 all the way above here, you're going to have that. Even though it's supposed to be 3 units up, it's supposed to be higher. But really, here's the graph. And remember, I want to draw the line for the new graph that I just created that I'm staring at. And that's when I check above and below. But it's actually above the whole time, unless you talk about x equals 3. That's why it's weird. It's above, then x equals 3. It's equal to 0, right? So horizontal tangent. Then it's above again. So you don't really see stuff like that on the AP exam. Here at 3, there's not an extrema. At -4, there's a min. And at 8, there's a max. Okay, so that's the only max. Okay, so, find the value of x. So max value of f, we'll say when x equals 8. But then you got to justify, and that's the weird thing. How do we justify it? Because if it's a relative extrema, we know we say the derivative equals 0, changes sign from whatever to whatever. On the endpoints, you don't have to worry about justifying, but here you do have to worry about why this is an absolute max. You could get the y values of all these if you want to, and then compare them and show this is the biggest. But you could also say because it's the only max on a closed interval, because it's the only max on a closed interval. Okay, so it's a little bit different. That's actually the EVT, just so you know, the extreme value theorem. So a little bit weird right there. I don't think you'll see it on the AP, so I wouldn't actually worry about it, okay? But it's an interesting type of situation there, okay? As far as x equals 8, it's going to be the highest point on that graph, really. Okay, so moving on to part C over here. So part C, and this is a little weird too. You won't see something exactly like this either. X approaches, limit as x approaches 0 from the left-hand side, okay, of g prime of x. Okay, so what that really means is g prime of x represents the slope of g of x. So as you approach 0 from the left-hand side, what's the slope of the tangent line approaching? And the thing is, the slope of the tangent line is not actually approaching anything. The slope of the tangent line is constantly this negative value right here. So you could calculate that. If they wanted the slope, if they wanted the limit as x approaches 0 of g prime of x, if they, just indicated a two-sided limit, then it wouldn't exist because there's a sharp point here. The slope coming in from the left, not equal to the slope coming in from the right. But you could actually do the slope coming in from the left. So the limit as x approaches 0 from the left-hand side of g prime of x equal to, it's just the slope of this line right here that has 0, 0 as a point, and also -4, 2 as a point. So it's just average rate of change, 0 minus 2 over 0 minus -4. Okay, and you could even leave it right there if you want to. It might be hard for that to, be read, like what the heck does that say? So I know it's really -2 over 4. It's a -1/2 right there. Once again, doesn't need to be simplified. And it's a little weird. They don't normally ask you for a one-sided limit at a place where a limit is non-existent, a place where a limit of a derivative is non-existent. But I guess it could happen. Then if you take the limit as x approaches 0 from the right-hand side of g prime of x, so what's happening to the slope of the tangent line as you approach 0 from the right-hand side? Look what's happening to that tangent line. It's getting closer and closer to being vertical, okay? So believe it or not, it's getting a slope that, right here it's actually a negative slope, but it's getting less negative, less negative, less negative, and it's actually approaching positive infinity there, okay? So really, the slope is non-existent, so this thing does not exist. They didn't really say to justify why, okay? Really what happens is the slope approaches positive infinity. Slope approaches, do I want to say positive infinity? Technically, it's negative infinity, right? If you're sloping downward this way, you're still approaching negative infinity, so we'll do it that way. Slope approaches negative infinity. So just be careful with stuff like that. Not that I really think that you'll see it. I don't think you'll see something like this. Even B is weird, and D is going to be weird as well. Remember, these are teacher-generated questions. Focus more on the one that's like this on your homework. But if you take a look at this, the limit as x approaches -2. There's going to be a limit somewhere on your AP exam, without a doubt, okay? And it's probably going to be a L'Hopital rule limit. This is L'Hopital's rule. Let's talk about some notation, because when you do this, when you plug in, right, directly substitute f of -2 plus 7 over e to the 3 times -2 plus 6 minus 1. The way I usually have this, write this up, and the problem is f of -2 you need, right? We can get f of -2. Remember, f of x is 3x plus the integral from 0 to x of g of t with respect to t. So f of -2, 3 times -2, plus the integral now from 0 to -2 of g of t with respect to t. So that's going to be what? -6 plus the integral from 0 to -2. Right, integrating backward the regions above. Okay, so that's going to be a negative answer right there if you integrate backward and the region is above, right? Integrate backward, regions above, yes. And it's this area, so this right triangle right here is a base of 2, a height of 1. So 1/2 times 2 times 1 is just 1. Just remember the integral from the integral from -2 to 0 would be positive 1. Integral from 0 to -2 is -1. So you actually get -7, okay? And you end up with -7 plus 7, which we know is 0, over this guy over here. This is really e to the 0, which is 1 minus 1. And we get 0 over 0. And that's usually the way I have you guys write it up. But on the AP exam, and I've told you this before, you're not really supposed to say it equals 0 over 0. If it's a part 1, no one would care. Really, if you do that in the AP exam, don't say it equals 0 over 0. Do this. Say the top approaches 0 and the bottom approaches 0. And that means it's a situation where if you try to take the limit of a quotient and the top approaches 0, the bottom approaches 0, that means you could use L'Hopital's rule. Okay, so a L'Hopital here, L'Hopital, and that just means take the derivative of the top and the bottom. So the limit as x approaches -2. Sorry about that notational thing. We've spoken about it, but look, this is all a part 2 exam. These usually don't show up on part 2, so it's usually not a big issue. But here, just make sure you put that, you circle this, it goes to 0, the bottom goes to 0 as well. Cross this out. There's nothing wrong with having that work. And make sure you have this, because you needed to know that, to know what f of -2 was, to know the top goes to 0. But if you take the derivative of the top, that's just f prime of x, right? Plus 0 over the derivative of the bottom, e to the 3x plus 6 times 3, chain rule, minus 0. So now you could evaluate this, okay, and get f prime of -2 over 3 times e to the 3 times -2 plus 6. So the bottom, we know, is 3 times e to the 1, which is just 3 right there, which is nice. The top is f prime of -2. Remember, if you want f prime of -2, f prime of x is 3 plus g of x. So f prime of -2 is going to be 3 plus g of -2. The heck is g of -2? It looks like it's 1 right here, okay, right? So it's just going to be 3 plus g of 1, 3 plus 1. So that's going to be 4 right there. That's how I know the answer is 4/3. All right, so look, a little bit of a weird problem here. Try not to worry so much about B or C. It's a little bit weird. D is a cool type of problem, okay? I'd say focus on A and D more for this one. But B and C, I mean, you probably won't get something like B because it's just a little weird. It doesn't show up. I guess you could get something like C. But the ideas of what we talked about, they're also important there, okay? So focus on that stuff. You know, moving on to the next one. And whenever you start doing problems that are created by teachers and not the College Board, things can be a little bit different from what we're used to in class. Try not to be so nervous about it, okay? During a chemical reaction, the function, if this is cut off a little bit, if you look at the answers, I think it's cut off less. The function y equals, that says f of t, models the amount of substance present in grams at time t equals seconds. Okay, so y equals f of t tells me how much of a substance is actually there in grams, according to what second you're talking about. At the start of the reaction, which is t equals 0, they tell you there's 10 grams of the substance. That's an initial value, okay? That's an initial condition right there, believe it or not. Then they tell you y equals f of t. They don't tell you what it is. They tell you it satisfies this differential equation. Then they want a little local linearity. Use the line tangent to the graph at t equals 0 to approximate the amount of substance remaining after at t equals 2 seconds. You know, normally it's not great local linearity here because 2 is pretty far away from 0. It's really kind of contextual. The contextual depends on the situation. But the idea is here, this is the best we could do because we don't know what f of t is equal to, okay? So we want to actually use the tangent line at t equals 0. Let's get an equation of a tangent line. First, we need the slope of the tangent line. Slope of the tangent line. Well, f of t is the original function, right? There's my OG. And his derivative is right here, okay? You don't need to take the derivative. You just need to take dy over dt and evaluate it at t equals 0, which bothers people because dy over dt doesn't have a t in it. It has a y in it. Remember, y is the amount of the substance, and they tell you there's 10 grams, okay, at t equals 0. So it's really when t equals 0 and y equals 10, okay? So we're just putting in negative 0.02 and then 10 squared. You know, you could leave it like that and not simplify, but it is a problem where you want to come up with a tangent line. This is really easy to do. It's 0.02 times 100, okay? So just move the decimal 2 to the right, and you end up with negative 2. That's the slope y'all looking for. But if you want, you could just leave the slope as this right here. There's nothing wrong with that. If you get what b is, so you plug in a y equals mx plus b, replace everything but the b. I know the slope is negative 2. I just got it. It's not really an x here. It's really a t, which is 0. And it is a y here. The amount of the substance present is 10. They told you that. So b is 10. So therefore, even though with 3 dots, we get y equals what? Negative 2x plus 10. Instead of negative 2, you could have this thing right here. There's nothing wrong with that. But remember, if you want to approximate the amount of substance at 2 seconds, so f of 2 is approximately negative 2 times 2 plus 10. You could leave it that way if you want. Okay, it's really just equal to 6. But you better put grams. Right, you want to make sure you put those units. When you don't simplify answers, sometimes you kind of forget about units. So be careful with stuff like that. So it's a little bit weird here as far as approximation. Usually we use decimal values and stuff like that. Once again, teacher-created problem, but still something you could do. Using the given differential equation, so using this thing over here, determine whether the graph of f could resemble this graph. Give a reason for your answer. It's a weird problem. We've seen it before, believe it or not. And a differential equation problem that we did, I think not during review, I think during differential equations. But they want you to use the given differential equation. And remember what that represents about the substance. It's the rate of change of the substance, you know, and if a rate of change is positive, something's getting bigger. And if a rate of change is negative, something is getting smaller, okay? So really you should be thinking about, you know, the substance amount increasing or decreasing, and dy over dt is equal to what? Negative 0.02 y squared. And if you want to think about increasing or decreasing, you want to think about whether this rate of change is positive or negative. Well, y squared is always positive, right? This is always positive. And negative 0.02 is always negative. So something that's negative times something that's positive is going to be negative, okay? So we're going to say since y squared is always positive, you know, you want to write it instead of just writing stuff like that. Technically, there's a time where it's not positive when it's equal to 0. So we'll say y squared is always positive when y not equal to 0. Okay, and y is the amount of the substance, by the way. You know, it's an exponential decrease here. Is it exponential decrease? Is it not? Regardless, the substance starts at 10, and then you're going to see it starts to decrease. So it's not going to be equal to 0 for really a long time, so you don't even need to worry about that. But y squared is always positive when y is greater than 0. Thus, you're always going to have a negative times a positive. Thus, dy over dt is always going to be less than 0. It's going to be negative when y is not equal to 0. What does that mean if dy over dt is negative? That means the rate of change of the substance is negative, okay? So that means, that means, what am I writing? That mensis, okay? That means, I can't even read it, I'll put it over here. That means that f of t will be decreasing, will be strictly decreasing when y is not equal to 0. Okay, you can see by this graph here, y is never equal to 0. It never actually, hits a value of 0 right here. But you can see that this graph is not always decreasing, okay? F of t is supposed to be strictly decreasing. This only decreases from here to here, but then it increases. But this slope can never be positive, okay? So it means f of t will be strictly decreasing when y is not equal to 0. This does not happen in the graph. This does not happen in the graph. So it can't represent f of t. This does not happen in the graph, so it can't represent f of t. Something like that, okay? So it can't represent f of t. So it's a little weird, okay? Maybe it's a little bit wordier than it needs to be. You could see something like that, a little something to think about. If you do see a differential equation problem on the AP, chances are they're going to have you solve the differential equation, what they do in Part C. I can't tell you how many points that's going to be worth, okay? But I know it's going to be worth anywhere from like 4 to up to 6 points I've seen, okay? It's a lot of points that they'll actually give you for solving a differential equation, so make sure you do it. This is stuff that we talked about during virtual learning. I really hope you put in your work and didn't slack off, but if you did, whatever, it's over. You're going to fail. Other people put in their work, good for you. To solve a differential equation, let's separate and integrate. The way to separate is to first cross multiply. Always put the dy on the left-hand side. And you can see that we're not separated here when we cross multiply. This y squared needs to be over here. Don't keep the left-hand side as clean as possible. Don't be bringing the negative 0.02 to that left-hand side. Just bring the y squared there. Divide by y squared on both sides. Same thing as multiplying by 1 over y squared. And don't be thinking it's an ln situation. That's only if you're going to integrate a quotient and the bottom is being raised to the first power. This is being raised to the second. I'd write it as y to the negative 2 dy equal to negative 0.02 dt. And you're already separated here, but now you have better means to actually integrate. All right, so integrate both sides. The integral of y to the negative 2, add 1 to the exponent, divide by that number. Negative 2 plus 1 is going to be negative 1, divide by negative 1, equal to, you're just integrating a constant with respect to t. If you integrated 3 with respect to t, it'd be 3t. This is going to be negative 0.02t. Don't forget to add c, and that is a general solution, but I always like to keep the left-hand side as clean as possible. I'd like to cleanse it of constants. This house is clear. It's from an old horror movie. Poltergeist, you ever seen it? Great movie, really scary. If you don't like scary movies, don't watch it. Kind of has a Stranger Things vibe. That whole upside down thing was kind of like in Poltergeist Part 3, I think? Or was it Part 2? I don't remember. Stranger Things, kind of watching it. Cool stuff. Hey, what? Kind of watching it. I am watching it. My wife is obsessed. Y to the negative 1. You could leave as y to the negative 1 or 1 over y. It doesn't matter. Negative 1 times negative 0.02t is going to be 0.02t. Just remember, negative 1 times a constant, just another constant. And that's the actual general solution I would use. Remember, they want an expression y equals f of t, so you have to solve for y, but you also need to get rid of that c, okay? And that means use that initial condition of 0, 10. All right, so when we plug in y equals 10, we get 1/10 equal to, make the t a 0. That's beautiful because it makes it really easy to solve for c, which is 1/10. So make sure you take that general solution you used to generate your value of c, plug back into that, and now you just need to actually solve for y. This is weird right now. Technically you could solve for y this way. You could just reciprocate both sides. Say 1 over y becomes y over 1 equal to 1 over, and then 0.02t plus 1/10. And you could stop right there. And that's absolutely correct, okay? And maybe it wouldn't be a bad idea for you guys to stop right there. What's really going on here is that 0.02 is really 2/100ths. Okay, so really you end up with 1 over y is equal to 200ths is really, we'll leave it as 200ths. How about 2t over 100? Same thing, right? Okay, plus if you get a common denominator here, multiply by what? 10 top and bottom. You know, if you want to flip both sides, you can only do it when each side is one single fraction. That's why you need to flip this entire side over here. And a lot of people wouldn't do that. They would flub that up. A lot of people think you just flip each separately. You can't just flip over addition. Just like right now, you can't just flip both of these. You need to have one single fraction on either side. And if you get the common denominators, then you do. Okay, it actually becomes y is equal to, flip this side, 100 over 2t plus 10. That's a better way to write it. Even better, by the way, is if you divide by 2, top and bottom, maybe factor out a 2 on the bottom, then divide by 2, the top is 50, bottom becomes t plus 5. That's the better way to do it, okay? I'd really stop right here on the AP. It's not necessary to simplify. If it was a part 1, you need to worry about stuff like this, okay? But practice those differential equations. You're going to see one for sure on your AP exam. I really think so. More practice on that on Monday, just so you know. Practice over the weekend as well. Part D. This is kind of cool. Determine whether the amount of substance is changing at an increasing or a decreasing rate. Explain your reasoning. You know, we know the rate at which the substance is changing. Okay, that's right here. That's our dy over dt. So you want to explain whether the amount of substance is changing. Okay, and the rate at which the amount of substance is changing, that's dy over dt. You want to know if it's changing at an increasing or a decreasing rate. So really, the amount of substance is changing at this rate, dy over dt. You just want to know if the rate is increasing or decreasing. And if you want to know if something's increasing or decreasing, surely there must be some sort of test. There is, the first derivative test. But we want to know if the rate is increasing or decreasing. Okay, so we want to know the derivative of the rate, which means I need d squared y over dt squared. Okay, so be careful. Really easy to take that derivative right here, by the way. You know, drop the 2 down like it's hot. 2 times negative, well, let's just keep the negative 0.02 in front. Then I'll drop the 2 down. The derivative of 2y with respect to t, the derivative of y squared with respect to t is going to be 2y dy over dt. I have no calculator. That's why I didn't bother multiplying those two things right there. You could, okay, it's not bad, right? 0.02 times 2, if you have 0.02 plus 0.02, 0.04, but don't forget about the negative. And also, this is not good enough. It's in terms of dy over dt. Okay, we know what dy over dt is. Okay, so d squared y over dt squared really equal to negative 0.04 times dy over dt, which is really negative 0.02 y squared, right? So really, when you multiply these two things, a negative times a negative is a positive. 0.04 times 0.02, what is that, 0.0008, I think. Okay, I have it on the solution, but you don't need it. You just need to know that that's a positive, and it's 0.04 times 0.02, whatever the heck that is, who cares, times, your y squared over here. And remember, this right here, this is going to be positive, right? Because it's a positive times a positive. And we also know that y squared is always positive. Okay, so since y squared is greater than 0, that means d squared y over dt squared, it's a positive times a positive, it's going to be greater than 0, okay? And if the rate of change of the rate of change is positive, that means the rate of change is going to be increasing, okay? So thus, the amount of substance is changing at an increasing rate, which is not so easy, okay? Do the best you can with something like that. Part A should have been good. Part B, a little tricksy. It's not the easiest thing in the world, but you got to think about it a little bit. Part C should also be pretty good, so I'd focus on A and C for something like this. D is definitely doable as well. Like I said, not like some other differential equation problems that you're going to see, but something to think about. Try the 2 for homework tonight, definitely, okay? The 2 for homework are from AP exams, so they're more like something you'll probably see on the AP exam. Then over the weekend, make sure that you actually try those problems that I post, okay? Monday, one last lesson, folks. Then I'll post a couple of review problems on Tuesday for you to try if you want. But who knows what time you're actually going to be waking up. If the AP is at 2 p.m., will you have time to practice those? I don't know. And the day of the AP, don't do too much, okay? I posted a formula sheet. I didn't mention that yesterday, but I posted it on Wednesday. You can take a look at that. Make sure that you get sleep the night before the AP, that you're rested and ready to go. Make sure you eat something. Don't be taking this thing on an empty stomach. And look, you guys are going to do great, okay? I know you're not going to think you do great, and I got kids all the time. After you take the AP, you're going to think you did terrible. Trust me, okay? All the time, kids are like, I got hit by a truck. It was horrible. I got a 1, definitely. They get 4s. I'm not kidding you, okay? So it's going to feel horrible. We'll text about it afterward. You can tell me how you felt about it. But really, you're probably going to do a lot better than you think, okay? So make sure you work this weekend. Don't slack. You can do it. You can do it. One more video lesson coming at you before the AP. Mr. Berto, signing off. Adios.